Hi, my name is CJ Craig. I'll be presenting our CSC 575 final project. Um, Vineet Dakuna and I worked on this project together. Um, this is the README file. You should reference this anytime you have any questions and need to go back. You can also find the link to our data set here in the description of how we approach the data set. Um, we'll look first at our mainly at our IPython notebook in this video. And so here you can see the packages that we implemented, mainly to deal with extracting the text and putting the text in various dictionaries in order to set up for the inverted index. Here is our training set where we have the ID, the product UID, the product title, the search term, and the relevance provided by the user. The relevance is on a scale of 1 to 3, from 1 being least relevant and 3 being most relevant in accordance with the product UID. We then have the product UID and description within the product description dataset. And as we can see, the number of search words in the training set is 11,795. We also took out the search terms without stop words, and then we created this into a data frame, and then we're now visualizing the data frame in a word cloud so you can see the most frequent words such as inch, light, door, wall. Then we're taking a look at the DF training set with the search terms without stop words. Here is the description data set and also taking out the stop words. We then turn this into a test data frame where we're only using the first 10,000 rows to have it perform more optimally. We're now entering the section where we're preparing for the inverted index. And basically these two dictionaries are taking the product UID and then the product description as the value. The product UID is the key in these dictionaries. We're then taking the total frequency as a dictionary. So now we're looking at the individual words for each product description and then looking at the word frequency, or the total frequency of those words amongst the different product descriptions. We're then looking at the amount of the occurrence of those words amongst different documents or amongst the different product UIDs and the document frequency. We're then calculating the IDF. This helps tamper down the values that show up in multiple documents. So if you have a value that shows up in multiple documents, or in our case, the product UID, then that IDF value will be lower. Now here's a look at our inverted index with the headings. And then we can see that we didn't include the document with its own individual because we're looking at many documents in this case, and we believe this would tamper with our performance of our code. We then took the document length, which will be used for our search and retrieval process, shown in the next function. For our search and retrieval function, this function searches the product description data frame based on the input values entered by the user. The process then splits the input values and determines the IDF value found from the previous function, from our IDF function previously shown. The value is stored in the dictionary, which having the product ID as the key. The process then continues incrementing the value of the dot product in the dictionary. The value of the dot product is then normalized, multiplying it against the document length, which we saw in the last function. We then sort this in decreasing order so the most relevant documents show. Next, we want to prepare for our benchmark data set. And so here we're using the evaluate search terms, which takes in input from a random sample of here shown in the DF train sample, and then the process splits the search terms and determines the IDF value found from the previous function and then multiplies it. The value is then stored having the product ID as the key. The process continues for all words, incrementing the value of the dot product in the dictionary. This is then sorted again so the most relevant documents occur. We then take a look again at our training set, and then we narrow it down to the search term, product UID, and the relevance, as these will be the necessary columns that we'll use. We then create a sample from the evaluate search result. showing the search term and, and the value, with the value being the product UID and the search term. These are then matched, and then we see the search term with the amount of NAs, and we index them where they're the same. This leaves us with the sample data frame. This sample data frame has 116 rows and 3 columns where they matched, and so we can see the product UID with the corresponding relevance. And we check that these are all unique, and now we're creating our benchmark data set where we'll be able to see the relevant documents. As you can see, we show the product UID, the search term, the relevance count, and the recall and precision. We can then visualize this as expected, or as what is usually expected for recall and precision. As we look at more documents, the recall increases, and as we look at more documents, the precision decreases. As we can see, our precision stays fairly high though, at around, and it only gets to about 93%. When we look at the averages, the average recall is 50% and the average precision is about 98%. We then want to visualize this in a GUI. And so this takes in a search term. And so we can look at the search term shovel. And this will return the most similar products based on this search term. Any further questions, you can refer to the README file or this Word document or PDF document going into depth explaining our code and project. Thank you for your time.